Hi, everyone. Welcome to the Pacific I/O Extended 2022 third session slot. Let me share my screen quickly. Just a second here. So we finished the previous session with the Raffle and session feedback form. And our upcoming presenter and this third session I'm very excited about. It's by James Daniels. He is a Googler, meaning he works for the Firebase division of Google. And that talk was about to be featured at Google I/O, but it didn't get into Google I/O. So this talk is a truly a Google I/O extended talk. So it's building modern web apps using Firebase. And here's James.
Hey there.
Well, I'm very excited about this talk. Truly a Google I/O extended talk, as you told that it was planned for Google I/O.
Yeah. We had a couple hiccups. Some last-minute feedback came in, and we decided to polish the feature a little bit, and we're ready to share it. Great. So, hey there, everyone. I'm James Daniels. Thank you for the intro. I'm a developer programs engineer on the Firebase team. So what's a developer programs engineer? So I work for the DevRel team. I work on the Firebase JS SDKs. And some of you may know me from ngconf, talking about Angular Fire, React Fire. I do a lot of our GitHub work. So I'm building things that help web framework authors like deploy their applications on Firebase. So today I want to talk to you about some of the new exciting work that we're doing to make it so that if you're building a modern web application, your developer experience is much better on Firebase. So a little bit of history, right? How did we get here? Where do we Where are we? What do I mean by modern web application? Right. If you've been a web developer, might be taking that for granted. So little bit of background. Also, I'm going to be focusing very much on JavaScript, sort of client side heavy stuff here. But TLDR, different people break this up different ways. But to me, we kind of had the DHTML era, where you had a server, you had a database, and then you rendered HTML that was tailored to that database and the user. That's old school. That's LAMP stack. That's Apache, MySQL, PHP, Profile. Nothing wrong with this stack, right? Once we got into this Web 2.0 era, we started sprinkling JavaScript in there. JavaScript originally was very simple, right? I think Ajax changed that, right? Ajax changed that. That allowed for, new interactions on the web. It allowed web applications to look more like traditional applications. We could fetch things from APIs, and naturally, developers wanted to abstract over it. This is where we got things like jQuery, Prototype.js, AngularJS, and basically, hey, I have a backend API. Let me alter the DOM, progressively enhance our web application, make it a little bit more robust. Then we enter the SPA era, single page applications. So if you have all this, why not just write all the HTML on the client, right? This is where we get into sort of more modern Angular, React, Backbone, build everything. This is a thick client model, right? We're reaching out to the backend. We're building this HTML. We're serving to the client. And this is your blank web page. Please enable JavaScript experience, right? This is in comparison at the time, right? We had Flash and the death of Flash and back and forth there, but just very much focusing on the JavaScript side of things. And now we're entering what I mean by modern web applications. My joke is, well, maybe we went too far with SPAs, right? Maybe there were good things about traditional web applications, rendering it on the server. And things that have made this possible are isomorphic code in JavaScript, some of the harder problems with data rehydration, and just the developer experience stuff is kind of getting sorted out. Examples of this is Next.js Remix, Nuxt, Angular Universal. And this is what I mean by modern web applications, right? We went from this era where we are just looking at documents to highly interactive, compelling, and performant applications, right? Google Maps was the first web application that I saw that was Ajax really clicked for me, right? This was not a pan around the map. It has to reload. This is JavaScript. Things are moving in. Images are sliding in. It's super slick. You got that little bit of inertia. You can smooth zooming out. That was a magical experience for me, right? We've gone far beyond that now. We have games in the browser. We have VR experiences, and we have rich media experiences like YouTube, right? The world is really more advanced, and these applications are quite advanced, where at the place where these are real applications, right? It used to be JavaScript, right? It was just a scripting language, and now things are much, much more robust. Sorry about that. Having a little issue with my computer. Back to the slides. And cool experiences like our new Firebase blog. Check it out. This is actually built on Astro. Great experience. And really taking it to the future, taking things to the limit, right? We have these Google Earth experiences, and pretty amazing. So how we've built these web applications have evolved, right? We've got to keep pace with user expectations. We've got to build abstractions to make this work. We got to keep up. Ultimately, you hear about JavaScript fatigue a lot, these burnouts and all this, and things are too complex. But to me, that's a developer experience problem, right? This is things that the tooling authors, the library authors, we can sort out. We can build things to make that simpler. And things that power this, right? Frameworks moving along this direction, simplifying these, right? React, Angular, Vue, Next.js, Nux, things of that nature, right? Really abstracting around this. You see a lot of common patterns here. You see the frameworks moving around, trying to solve these problems in different ways. And we're kind of like circling around. We're finding good patterns. And how can we enable this, right? How can we enable these developers? And ultimately, like I said, we're going back to a world where, hey, the server is still relevant, right? We have stuff rendering on the client, but we can't do it all on the client now. Maybe we want search engines to crawl the site. Maybe we have experiences that are too computationally complex. And maybe we just want to reduce the load on our backends, security, things like that. There's a lot of merits to traditional web applications. And now you're seeing the technology sort of meet back in the middle. So back to Firebase. So we're very much from the single page application era, right? Firebase hosting is serving your static websites, but our mission has been around simplifying app development, right? We want to make app development and app development on Google Cloud super simple. We want to be that opinionated. You go to us if you just want it to work, and if you want to tweak with how things function in the back end, you can go ahead and drop down to those Google Cloud primitives. But our ultimate mission is to simplify app development, make you move faster, let us focus on all the details and nitty-gritty of getting it up and running on Google Cloud so that you can move faster and focus your energy on the things that make your app unique, right? Not the things that everyone else is facing, how to get a Next.js application running on Firebase, but the things that like you're trying to solve. Let you focus on those while we deal with the background. So in this world, right, if you build a Next.js application, how do you get that running on Firebase? How do you get an Angular Universal, a Nux app? Like, that's very complicated. This is where our new Firebase deploy tooling comes to. So our new tooling does three things, right? We discover, we build, and we deploy. Discover, we look at your application source code. How do we build it? What framework is it? What CLI commands do we need to trip? There's a discovery process. So we look at your code. We figure out what infrastructure does it need. Is this a static application? Or is this dynamic? Do we need to spin up a cloud function or some other backend capabilities? So we do that in our discovery process. Next, we build your application for you. So we build your application. We run the build command. We inject any Webpack config. Potentially down the road, we're looking at tighter integrations with the Firebase emulators and the Firebase product suites. So how do we build? How do we tie that in good to your emulators, whether it be a dev build or a production build? Then, we look at deploying. The build step needs to tell the deploy step, well, where are the static assets? This is a really deceivingly simple problem, but there are hundreds of web frameworks. Like, how do they build things? Where do they put their assets? And how do we know what, where, and how to spin up a backend for them, right? This is what our new tooling focuses on. So the two main technologies at play here are Firebase hosting and Cloud Functions for Firebase. So Firebase hosting is a static web application hosting provider. We have a global CDN. You get free SSL certificates, preview channels, so you can link things to GitHub Actions and see previews of your web content. That's a great product for static. There's Cloud Functions for Firebase. Generation 2 of Cloud Functions has just shipped, which is built on top of Cloud Run, which is Google Cloud's premier serverless product. And this is a backend. You're spinning up a Node.js server. This can run code. And what you can do is you can have a fallback pattern. If the content is not on hosting, it falls back to the Cloud Function. And we can set cache control headers and all that. Our tooling takes care of all this for you, so you don't have to know how to spin up your application on top of Cloud Functions. So the 3 tiers here, right? So we have client-side rendering, static site generation, and server-side rendering. I know like these are kind of blur into each other, but I like to look at them as a funnel, right? A lot of applications are still very much in the client-side rendering, right? This is content that when you build it, when you deploy it, it's sent directly to Firebase hosting. And this is configured as an SPA, so single page application, where any URL you hit gets redirected to your index page, which bootstraps your JavaScript, your HTML. So client-side rendering, this is very much the top of the funnel. This is a lot of applications. The next tier is static site generation. This is where this new generation of products, frameworks is getting really interesting, where you go ahead and you build the application, and it'll create a multi-page application. This is all stuff that's done on your machine or your CI/CD server. The great thing here is people share content, so you pre-render it at deploy time, and they share it. Think catalog of products, right? So you have an e-commerce experience. Every time you deploy, you want those pages as HTML, something that search engines can crawl, and something very, very performant. And you know the list of products, so you can go through and pre-render those. So this is static site generation, SSG. And this is where we start bleeding into that MPA multi-page application story, where it's starting to look like a traditional server. This is just in the middle, where you pre-render everything, push it up to the CDN edge. Finally, we have SSR, so server-side rendering. And this is dynamic, on-demand content that you fetch the content from your database and you render it on the server, and it's unique for each user, not shared. This is, you can have this as a fallback pattern to SSG. Say again that e-commerce experience or a blog post. Maybe you have user-generated content where if it's available and you know of it, you pre-render it. But you're not going to pre-render your entire site every time, someone adds a new post to your website. So SSR is a good fallback here. And I see this, these blur together, but I see it in kind of progressive complexity that the developer needs to think about. So jumping into the frameworks, right? What do these mean? How do you trigger these? How does the Firebase tooling determine which one of these your application fits into? So I'll throw out a couple examples. We have Next.js, Angular, Express, and Nuxt right now. So I'll throw out some examples of things that would move you through the funnel as your application gets more complex. So for Next.js, if you just render your components purely client side, it just gets deployed to hosting. If you have get static paths, get static props, I18N, and simple rewrites or redirects, this is stuff that the tooling knows how to put it on hosting. It's all fully rendered. It knows that your application has rendered all those routes. And it goes ahead and puts that content up on hosting for you. Then there's SSR, right? When do you need a cloud function? When do you need a backend? For Next.js developers, this is if you're using Git server-side props, image optimization, or you're doing complex rewrites or redirects. So things that, complex G-subs, fetching content from other servers. This is stuff that will trigger a cloud function. Why does this matter to you? Well, cloud functions cost money, right? You need a billing instrument in place, a credit card in place in Google Cloud to be able to use cloud functions. You need our cloud build, which deploys them. Hosting has a instrument list free tier where you don't need to put a credit card. So just keep this in mind. And these are all just kind of progressively things that you'll have to deal with. But this is sort of how our tooling determines, right, whether or not you need a backend. For Angular apps, it's simple. We look at whether or not there's Angular Universal. For SSG, we just look whether or not you have predefined routes to pre-render or guest.js, and whether or not those have exhausted your entire route tree. For SSR, there's just universal and a server target, and you could opt out of universal and just do pre-rendering if you skip the server target in your Angular JSON. For Nuxt is in an interesting position. Nuxt 3 is in RC now. We're very much focusing on that experience. Their SSG story is developing. But we've hooked into the right APIs so that if your site is fully rendered, which is something that the Nuxt compilation tool tells us, it's fully rendered, it's exhaust all of its static routes, that it'll be treated as SSG CSR, else it'll spin up a cloud function for you, so if it's not fully rendered. And finally, there's Express. So Express.js is interesting. So right now we have Angular, Nuxt, and Next as our pre-release frameworks that we've targeted. We've also added Express.js, so you can add support for web frameworks in our new just Firebase deploy. It'll build everything for you. You can do this just in your package JSON. So there's a set of conventions by which you can abide that will build your application for you, regardless of your framework of choice, or maybe your mixing frameworks. And you just indicate that by having an exhaustive npm build step, and you add a directories.serve option to your package JSON. If your application can be bundled, and that bundle includes exports a Express app or an Express style URL handler, we will know to treat the application as SSR. So that's a lot of words, right? Those some slides. I mentioned a lot of concepts without a lot of clear. Oh, add this to your package JSON, deploy it. What does this look like? And this is where I'm gonna jump to code, right? I'm an engineer. I like to show off the code, show what we're building, and this comes with the caveat. This is a live demo, so subject to the demo gods, right? So here I have a Next.js application. I've added some scripts. This happens to use some pre-rendering. So I have my Google application credentials and this environment variable. Beyond the environment variable, though, it's just Firebase serve and Firebase deploy. Super simple. Looking at what I have for code here, so I go to my pages. This is super simple. It's just spitting out some stuff from Firestore. I have some products with a wildcard ID, and we have our index TS. So here we have some get static paths and get static props, and we render our component. So we're actually getting our data from Firestore. Get static paths tells us which paths we should pre-render. So here we're actually getting stuff from the Firebase admin SDK. So we're looking at our collection products, we're listing the documents, and we're grabbing their ID. That ID parameter maps to this path wildcard. Next.js is pretty cool. I like it a lot. It has a file system based router. Yeah, it's interesting. I like it. And we get that idea, it plucks that, and it passes that into that, and that determines when it pre-renders what URL will be served just through the file system. So that's what paths to render. We actually go ahead and get static props is where we fetch our data from the server. So we go ahead and we get admin Firestore products. We grab the ID off the parameters. We get it. If it exists, we go ahead and grab this. I'll touch on the bundle in a second. Else, we return F404. The product did not exist. So this here will go ahead and trip SSG, static site generation, where it'll pre-render these these pages for us when we deploy the application. If these were Git server-side props, it would trigger SSR. But for simplicity, we'll focus on SSG. Then we get to our product. We passed some initial data from the server. And this is a more advanced case. What we're doing here is I am actually using React Fire to make the data, when it rehydrates, it becomes real time. So we go ahead and we will render that initial data on that first pass, but then we'll go ahead and we'll grab the product and rendering it on the page. So we'll go ahead and render that, just JSON data. So if we go ahead, so that's the code. If I go ahead to my terminal, and I'll go ahead and go npm run serve. This will actually spin things up locally and connect things to my Firestore emulator. And behind the scenes, this is just calling Firebase serve. It does have that environment variable of pulling my service account. That's needed just for fetching things from the admin SDK and initializing it that way. So it's gone ahead and rendered these pages. So you can see it's rendered product 1, 2, 3, 4 and some random strings. Took a little bit. If we go look at our .firebase directory, this is just peeking under the hood a little bit. We can see it's built our site. It has a functions and hosting directory. This is all the stuff that's going to get deployed to Firebase hosting. And we can see that those pages pre-rendered. So just a peek behind the curtains here as it spins up our website. So now it's spun up the hosting and the functions emulators. I can go ahead and click this. And super simple, engineering demo. Lots of, it's rendering some JSON. The cool thing here is if I go ahead, and this should be real time. So I'm going to go ahead and I'm going to spin up the Firebase console over here. I'm going to go to my demo, and I am on product number 2. So let's go to Firestore. Products number 2. And we change that to Hello World. There we go. So this is real time. This also connects the offline capabilities of Firestore. Firestore is configured in offline mode. Now, this is where the data bundles come in. So Firestore offline and pre-rendering. So imagine I left this page for a little while and the data changed and then the page was redeployed. The data that is in my browser's offline cache might be out of date. So this is where Firestore data bundles come in. So what the data bundles do is this is actually seed data for the website for my Firestore instance. So I go ahead and I bundle up the data, I give it a name, I add it, I send it along. In React Fire, I have a load bundle which does some things behind the scenes. But what this bundle is doing is it's actually serializing the data from Firestore. That way, when we render this page, say we go back to it after some time away, if I didn't have this, you would see a flicker of old content where you'd see some newer stuff that was pre-rendered. Then my offline cache came online, rendered some older content before it went and fetched the new stuff from the server, right? That's how Firestore offline works. But you get into this weird conflict when you have SSR, right? Because you're rendering some stuff on the server. Maybe the stuff on the server is newer than your client. You don't want that bad experience of flickering of old and new content. Imagine an e-commerce example, right? Where you've changed the price of a product. You wouldn't want a user to navigate to the page and see the price change, right? As they're poking around. And this is where those bundles come in. So what the bundle will do is it'll go ahead and before the client takes over, it will make sure that your Firestore offline cache is at least as up to date as the stuff fetched from the server. It'll load that into the offline cache before then establishing the connection, showing the offline data, and that. This is yeah, it's a lot, but there's some really cool stuff coming in here. This is all static. This could be, of course, server-side props, and this could be in any of our frameworks. But the really cool thing here is that, you know, this Firebase, simply calling Firebase serve and deploy, knew how to build our application. It knew how to spin up cloud functions. It knew how to pull these static assets from Next.js, Angular, Universal, Nuxt. It understands all of that and goes ahead and builds it and knows how to host it on Firebase for you. So this is great if you have a Next.js application, if you have a Nuxt application, if you have an Angular Universal application. How does this work if you are not one of those frameworks, right? You can go ahead and you can go to our GitHub. This is all open source. You can open an issue, say that we don't have your favorite framework. I like to build blogs on Astro. Maybe we don't have Astro support, so maybe you can file that as feedback and, you know, either contribute it yourself or hopefully prioritize it. But this is where our custom implementation comes in. So if I go ahead and I pull up our other example here. So I'll go to examples, custom. So I mentioned a set of conventions. So here I have a simple Express.js application. It's not using a framework. In fact, it's not a real application at all. It's a demo application, but it's not using a framework. We're using Spack here, and we're going ahead and building things. So in order to support any web framework, we need to answer those questions. How to build it? Where are the static assets for when it's built? And how do we bootstrap a backend if we want a backend? So here we have a set of conventions. So first and foremost, we have an exhaustive build step. npm run build, right? In the Node ecosystem, we have that build step. So we run Spack, we build the static assets, and we pre-render them. And I just have a pre-render script here, copying some static assets to lib. So everything here is posted in lib, right? So where are the static assets after it's built? This is where directories. This is a CJS thing. We added the serve field here. This is new. But this is telling Firebase when it deploys this to the CDN, where do we find the assets? So we look at the serve lib directory. So everything in the lib directory will get pushed up to the CDN edge. Now, how do we spin up a backend? This is where files and main and all that comes from. So the idea is just like an NPM library. If your web app is bundleable, so if you could package it, turn it into a tarball, you're not shipping it to NPM, but if you did, this is how you'd tell it where to find the files, right? So you're telling it to send up everything in lib and server.js, and you're saying that your main entry point is server.js. So the Firebase tooling, when it builds your application, will look into that main entry point, and it will look for an export named app. And if it sees an export named app and it's duck typed as an Express.js application, you could also have an export handler, which is an Express style handler. But what we do is we look at the general shape of it. If this is a factory that produces an Express.js application, we know to treat your application as SSR. So you can go ahead and deploy this on Firebase without, us knowing how to use your specific framework or set of frameworks or anything like that. This is a set of conventions by which we can understand to deploy your application. So yeah, that's Next.js. We also have the same tooling for Angular Universal, for Nuxt, and those are a work in progress. So that's what it looks like. You can just, to play around with it today, you can just open Sesame framework awareness for Firebase. That will go ahead and enable the pre-release feature. And you can call Firebase serve to spin up the local emulators, try everything locally, experiment with things, and if you like it, just type Firebase deploy. It'll go ahead and send it up to Firebase. You'll get the awesome and free Firebase hosting, which will distribute your application to the CDN Edge, have preview URLs, a free SSL certificate, and if your application needs it, it'll spin up Cloud Functions for you and handle the server side. Now, how can you get involved, right? Check out our GitHub. Right now we're on Firebase Extended. This is sort of very early preview tooling. So check out Firebase Extended, Firebase Framework Tools. You can check out the source code, how we're doing things, file issues, send pull requests if you're interested in getting involved, and adding your favorite framework. So thank you very much. I'm James Daniels. You can find me on Twitter. Here's some resources here. You can go to these links to learn more. Do check out Firebase on Twitter and the Firebase YouTube channel. We have some other great content that came out of Google I/O, so if you haven't caught up with all that, check it out. This is early preview work. I look forward to as many of you as possible getting involved with this, trying out what we've built, and helping us shape the future of modern web frameworks on Firebase. Expect to hear more from us at the Firebase Summit and upcoming events. Thank you.
Thank you, James. So let's see, I am peeking at the YouTube stream. If anybody has any questions, I don't see a question right now, but we will wait just a little. Until we have a question, maybe I have a question that we peeked into the hosting directory, and I'm just curious what's in the functions. What do you generate there?
Oh yeah, that's a good question. How this actually works behind the scenes is really interesting, as this is all based off code generation. So what we're doing is we're going ahead and we are building a cloud function for the developer, right? The idea is that we constantly get this feedback of you're Google, you're smart, do it for me. So that's kind of where we're going with the tooling. So if we actually poke in the functions directory, what we have here, this is the Next.js example, we have the .next directory, all the compiled assets for the application. We also have our server.js, our main entry point. And what we're going is, this is actually the code generated function here, where we're actually pulling in a Firebase aware server. This will connect the emulators. We'll await those, pull everything in, and then we'll go ahead and we write the cloud function for them. And there's actually some cool stuff that we're working on here, right? This is a bit of a teaser, seeing this Firebase aware server. But TLDR, we're working on some integrations where Cloud Functions can become Firebase aware. Again, that's one of those things that we've kind of left up to the developer. How do you log in a user on the server? How do you connect up the Firestore emulator and the real-time database emulator, right? These are things that as we're getting more opinionated and building out tooling for the developer and building their application, we can be opinionated it and have a more modern developer experience here.
Oh, I see. That sounds great. Basically, I like conventions.
Yeah.
Ideally, with very minimal plumbing work, it just works. I need to revisit and experiment with this.
Yeah, before I came over to Google, I guess 6 years ago now, in a prior life, I used to be a Ruby on Rails developer. A lot of Firebases were, is pretty interesting. But I really like that, if I took anything from that community, it's convention over configuration, right? And this is where, we're influencing web frameworks. It's, hey, you're using Firebase alongside a React application. We know what that is. We know how to build that. We know how to connect up the emulators and everything. So we'll make the assumptions for you. We'll build the backend for you. If you want to change some of those assumptions, right, this is where you can drop down into the cloud tooling, get your hands dirty. But by default, things should just work out of the box, right? We're looking for that. I remember years and years ago, right? This is Rails, but like seeing that demo that was given where they built a blog in 10 minutes, which was like very magic, right? Traditional Heroku, right? You took that blog you built in 10 minutes and you just, push it up to Heroku and it just works. If I'm looking at what motivates me and what experience I'm aiming for here, it's in that direction where like things are very automagic. We make those assumptions, we get things running for you. Because honestly, the time that you know the least, right, is when you're pushing your application up for the first time, right? You need to figure out the business side, what your product is, what differentiates you from your competitors. You shouldn't be having to learn the ins and outs of cloud functions and how concurrency affects, authentication models for cloud functions, right? And handling cookies and all that stuff. That's a lot of front-loading knowledge that you should be able to defer as long as possible. So that's the model that we're going for.
Sounds good. I like that a lot. We are still waiting for questions. I don't see any, but for any attendees, I would like to ask you to fill out the Raffle form, which is also an event survey form. Since it's a Raffle form, it's not anonymous because we want to connect back with you. So, yeah. All right, there's the link on the screen as well. You will you see it, and wow, this was such a great presentation. Thank you so much, James.
Oh, thanks for having me.
And I think we will take a little break, and I wait a little bit for the attendees to fill out the form, and then we will have a raffle. I forgot to tell the prizes. I have two Google Earbuds A type earbuds and a Chromecast with the Google TV remote. So we're gonna raffle off 3 items. So that's why it's worth filling out the survey form. Thank you so much again, James. And
Yeah. And for anyone that's not feeling like speaking up now, if you have questions, you can reach out to me on Twitter and check out what we're building on GitHub. Go ahead and file issues and get involved. Would love to have your pull requests.
awesome. Hey, Pacific Google I/O extended attendees. So I was waiting for some submissions of the form, and we conducted a raffle for one item. So we have 3 items total, and 2 of them is Google Pixel Buds A, and a third one is Chromecast plus Google TV remote. And the winner, so here's raffle time. So what we are thinking, we raffled off one item. I'm gonna announce right now the winner, and we will wait a few more days if anybody is submitting the raffle form, and we will conduct 2 other raffle rounds, and we will contacting the 2 other winners within some days, who will get the rest of the items. So I'm sorry, just switch here. Actually, I would say I'm conducting the raffle right now in the back, and so we have 2 winners, and I would give the 2 Google Pixel Bud A Bluetooth earphones to these 2 winners. One of them is Sherry Xu, and the other one is Krisa Jones. Krisa Jones, I hope that I pronounce your names properly, but you are 2 winners, and you won Google Pixel Bud A Bluetooth headphones. Congratulations to you. And later, we will wait with the last item. If somebody is submitting the survey form later, we will refer off the Chromecast and the TV remote within some days. Thank you so much for attending again. I would want to mention again the DevFest, upcoming DevFest season. These are even larger one-day events than this I/O Extended. They will cover a wide variety of topics. Each DevFest differs a little bit, but watch out for those, and also check out in general. There's so much going on right now, since still most of the meets are either hybrid or virtual. Let's say if you want to prepare for a Google Cloud certification, I think GDG New York and some East Coast GDGs are organizing a series, many of series events where they help you to prepare for getting a cloud certification. Or you are interested in machine learning. There's a 4-part machine learning study jam. I think the first already happened, but don't be worried. Since that's the first one, I think you can still catch up, and just watch the recordings and search on the gdg.community.dev website. You can find those GDGs. There are several of them who are teaming together to conduct these events. And there's too many topics to mention here right now. You can find your favorite, whatever it is. One of my favorites is Flutter. There's a lot of Flutter events going on as well. So thank you so much for being with us, and I hope to see you in the future. You can find the recordings of these sessions at the GDG channel, YouTube channel, and reach out to us either through GDG Fresno or any other handles, any of the speakers, if you have any questions. Thank you so much again, and have a wonderful weekend. Cheers.